question 7. We need to prove algebraically that 4n plus 1 to power 2 minus 2n minus 1 is an even number. So we need to prove that that's an even number. Well, we know first of all the definition of an even number. So an even number will be, let's say 2m is an even number. So that's even number equals 2m, and obviously odd number would be 2k plus 1. So that's how we define an even number. So the next thing we need to do, remember the letter can be any letter. It doesn't have to be M or K. So what we need to do next is to basically do the expansion for the two brackets. So we got two brackets. One is 4n plus 1 squared minus bracket 2n minus 1. Now I need to do expansion for, okay, if to do a square bracket, I know I need to do a plus b squared, and that will be a squared plus 2ab plus b squared. And that's the expansion for a plus b squared, where my a is going to be 4n and my b is going to be 1. So I can put that in here. So so what I'm going to do is I'm going to expand this now, and so I'm going to get 4n squared plus 2, and my a is 4n and b is 1, so it will be times 4a times 1 plus I got b squared, which is 1 squared, so that's just 1. So that together is this bracket here. And then I need to do the minus. So minus times 2n is minus 2n. Minus times minus 1 is plus 1. Now what I need to do here is collect the like terms. So 4n squared is 16n squared plus 8n plus 1 minus 2n plus 1. I haven't collected the like term yet, so I'm just finishing the expanding the bracket. Now to collect the like terms, so I would get, well, actually, I just need to write them clearly. So I will get 16n squared plus, now I have got 8n minus 2n, that'll be 6n. And then I've got 1. So I've got 1 plus 1, that'll be plus 2. So that's what I've got now. So 8n minus 2n is 6n. To finish it off, 2 is a common factor, so I take 2 out, so I get 8n squared plus 3n plus 1. And if I say let 8n squared plus 3n plus 1 equals p, where p is an integer, also bear in mind that also m and k will be an integer. Or indeed also n. n2 will be an integer. So I could say where p, or just say n, is an integer. So 8n squared plus 3n plus 1 equals p. Therefore, I've got 2p, which is even. Question 8. An isosceles triangle. So if I draw isosceles triangle, just before I actually continue reading that. So this is my triangle. Isosceles triangle has 2 equal sides and 2 equal angles. And it says an isosceles triangle has 2 identical angles, each measuring y degrees. So this is going to be y degrees, and that's y degrees. And another angle measuring x degree. So that will be x degree. Given that y is an odd number, prove algebraically that x is an even number. Right. So we need to describe the odd number first. So we need to say, well, let the odd integer sorry, that's how you spell integer, y equals 2n plus 1, because that's the definition of odd number, 2n plus 1. And the angles in a triangle all add up to 180 degrees. So total angle in a triangle add up to 180 degrees. I've got 2 y's here. So what I'm saying is 2y plus x should be equal to 180 degrees. And that implies that I'm going to have, well, I know what y is. So if I substitute y, bear in mind that x, y, and n are all integer. So if I substitute y to be 2n plus 1, so I get 2 into bracket 2n plus 1 plus x equals 180 degrees. So in that case, I would get my x value. Well, let me just continue expanding this. So I'll get 4n plus 2 plus x equals 180 degrees. And therefore, x will be equal to 180 degrees minus 2 minus 4n. So x will be equal to 178 degrees minus 4n. So that's what x will be. Now, in this case, what do I need to do is I need to, let me just draw this line here. So now I need to take that x, so let's say, and there's a 2 common factor here, so x equals 178 minus 4n. 2 is a common factor here, so I would take, well, 178 divided by 2, that would be 89. So 89, as 2 is a common factor, minus 2n. And I do know that I did say that y, x, and p are integers, where p equals 8n, sorry, 89 minus 2n. So I'm going to have 2p, and that gives me even number. X is even number. Question 9. Disprove the following statement. AX equals BX implies that A equals B for all rational numbers, A, B, and X. Well, in this case, so what we need to do, first of all, is to say, we could say if X equal to 0 and A equals to 1 and B equals to 2. So what we're saying is, from the equation we got AX equals B. If X is 0, A equals to 1 and B equals to 2, then applying the equation AX equals BX, which meant that 1 times 0 should be equal to 2 times 0. And therefore, that's 0 equals 0. So therefore, AX equals BX. So that's true in that case. But in the second case is if you to say that B, but 1 is not equal to 2. As you can see, A is 1 and B is 2. And therefore, so A is not equal to B. A is not equal to B. So what I've done is disprove this case, because A is not equal to B. The case says it implies that A equals to B, but A is not equal to B because A is 1 and B is 2. So A is 1, B is 2. So therefore A is not equal to B. So statement is false.